Hi, and welcome to video 5 of Module 1. In this video, we're going to talk about a couple of different kinds of studies that you can do if you're trying to gather data or information on a particular topic. I will mention that this video just kind of skims the surface on these different types of studies, and there are a lot of different ways that you can amend them to make them more particular for whatever it is you're trying to study. Okay, so before we can talk about the different kinds of studies, first we've got to get through a bunch of vocabulary. So when you're conducting a study, you'll be examining a particular group of, could be people, it could be objects, it could be, animals, bacteria, highways, whatever. Whatever it is you're examining in your study is called the subjects. So the subjects are who or what you're studying in your experiment. Then, as part of your study, you're going to be doing something to the subjects. Maybe you're injecting a certain chemical into the bacteria. Maybe you're applying a treatment to certain highways to prevent cracking. Different kinds of things. Whatever it is you're doing to the subjects are called the treatments of the experiment. So the subjects are who you study. The treatments are what you do to them. Then, as a result of the treatments, you're going to collect some information. So this could be the response of the bacteria to the chemical. Maybe the bacteria changed color. Maybe it doubled in size. Maybe it died. Maybe the treatment that you applied to the highway caused fewer potholes in the winter. So you would collect the number of potholes. Whatever information you are collecting as a result of the treatments are called the outcome, or sometimes the response variable. So the outcome or the response is the information that you are measuring as a result of the treatments applied to your subjects. Now, when you apply a treatment, you want to be able to compare it to if you had not done the treatment at all, right? So often you'll divide your subjects into two groups. The group that gets the treatment and the group that doesn't, or the group you're going to compare it to, sort of a baseline. So the baseline group is called the control group because you're kind of controlling the initial conditions. Now, sometimes you're going to want to administer a kind of non-treatment treatment to your groups. I know that sounds weird, but we'll get into why in just a moment. So when you administer this kind of fake treatment, it's called a placebo. And a placebo is generally a sugar pill. What that means is it's a pill just made of sugar. It does literally nothing to you. So to understand why you might want to administer a placebo, think back for a moment to when you were a little child and maybe you fell down or you got hurt, you had a little boo-boo, and you went crying to somebody for a Band-Aid, and they gave you a Band-Aid, and as soon as you put it on, magically you felt completely better. No more boo-boo, no more pain. So it turns out that human beings have a psychological response to things that they think are going to help them feel better. And if you think that you're going to feel better, you actually do have a physiological response. So if you think you're going to feel better, you actually do a little bit. So to counteract that in medicinal trials, we'll give one group the medicine and we'll give the other group the placebo. So both groups are going to have that tiny little expectation of physical improvement so that we can counteract what's called the placebo effect. In this video, we're going to look at two different types of studies. And again, there are a lot of variations on these kinds of studies that can be done. We're just going to get kind of a brief overview of them. In a randomized experiment, the person who's conducting the study assigns subjects at random to the different treatment groups in the study. So, for example, suppose I want to know if kids who have 40 minutes of recess every day perform better in their classes academically. So in that case, I might go to a school and I would take a simple random sample of students and they would get 40 minutes of recess every day, and I would take another simple random sample of students and they would not have recess. Maybe they would have kind of a reading period or a napping period or something different, or no thing at all, and then I would compare those two results. So either researcher gets to assign the treatment, and it is assigned to the subject using some kind of random sampling, either a simple random sample, stratified, cluster, or so on. In an observational study, the subjects self-select their group. And the self-selection could be voluntary, or it could be not really voluntary, just kind of by chance. So For example, another way that I could try and learn whether recess helps students perform better academically or not is study a school where they had recess and a similar school, so similar in size, similar location, similar demographics, that didn't have recess, and I would compare how those two schools did. Typically, observational studies are done when randomized experiments cannot be conducted. For example, if I want to see the effects of smoking and insomnia, see if there's a relationship between those two things, I can't really tell a group of people, hey, you guys have to smoke a pack of cigarettes every day, and this group you can't smoke at all. So more realistically, what I would have to do is I would go to a group of smokers, collect a group of people who smoke, track their sleeping habits over a period of time, and then I would go to a group of people who don't smoke and track their sleeping habits over time and compare the two. And I would try to make the two groups as similar as possible in all ways other than smoking. Also, sometimes the treatment might not be a voluntary choice. For example, it could be having a particular genetic defect, or maybe it's a certain disease, like brain cancer. So in those cases, we would conduct an observational study where the treatments have either already been applied or the subjects are choosing to apply those particular treatments. Be very careful with the terms that are used here because it can be a little bit misleading. For example, an observational study could have randomization as part of it. I could go to a city and I could find a simple random sample of smokers and a simple random sample of non-smokers from that city. I'm not randomly assigning the treatment, but my sample is still selected randomly from each of those groups. So an observational study can have randomization. You want to see how that randomization is applied. So main difference if you're trying to identify whether a study is a randomized experiment or an observational study is who has assigned the treatment. In a randomized experiment, the person conducting the study assigns the treatment. They have all the control. In an observational study, the subjects self-select their group, so the subjects get to decide who gets which treatment. Alright, so let's do a couple of examples to make sure we understand all of the terminology in play. In this example, a pharmaceutical company is testing a new headache drug. The researcher gathers 280 patients who suffer from regular headaches and assigns a simple random sample of 145 of them to take the new drug, and the remaining 135 take a placebo. During the week, subjects recorded the frequency and the duration of their headaches. The subjects taking the new drug experienced fewer and shorter headaches than those taking the placebo. So it's a good thing, right? The people taking the medicine had shorter headaches and they didn't have as many as those who were taking the placebo. So I'm going to ask a couple questions. If you want to, you can pause the video after I ask each question, try and answer it on your own, and then you can check your answer, or you can just kind of follow along with me. So question number 1 is asking, who are the subjects? Who did we examine in this study? Well, if I look at the second sentence, it says that the researcher gathered 280 patients who suffer from regular headaches. So the subjects of this study are people who have headaches on the regular, people who typically have a headache. So people who get headaches regularly. 2, what are the outcomes? Remember that the outcome is the thing that I am measuring. It's the response to the treatment. So what is it that we measure? What information did we gather from the subjects? Well, we gathered how often and how long their headaches were. During the week, subjects recorded the frequency and the duration of their headaches. So the outcomes are 2 things, the frequency and the duration of the headaches. So what were the treatments? What did we do to the subjects in order to elicit those outcomes? This one's not too bad. Some of the subjects took a drug, and some of them took a placebo. So the treatments are the new drug and the placebo. And the last question, what type of study was conducted? Is this a randomized experiment, or is this an observational study? Remember to tell the difference. You want to see who assigned the treatment. So in this case, who decided which people got a new drug and which people got the placebo? In this case, the researcher assigned a simple random sample to take the drug and the others to take the placebo. So because the researcher is assigning the treatment, this is a randomized experiment. Okay, so let's look at a second similar kind of example. France's Bordeaux region has one of the highest recorded rates of brain cancer in the world. Researchers suspected that the pesticides used by the farmers on the vineyards may have been at fault. They compared 221 adults from the region who developed brain cancer between 1999 and 2001 with 442 adults from the general population without the disease, who were the same age. It was found that the overall risk of brain cancer was 29% higher among those who were exposed to pesticides. Okay, so let's look at the same questions as before. Number 1, who are the subjects? Who are we studying in this study? Well, because it has such a high incidence of brain cancer, the Bordeaux region of France is our focused region for this study. So the subjects are people from that region, from the Bordeaux region in France. Number 2, what are the outcomes? What information have we collected? In this case, we suspect that pesticides may be a reason that people have developed the brain cancer. So the outcomes are whether people have developed brain cancer or not. So having brain cancer or not are the outcomes of this study. What are the treatments? Those are the things we think may have caused the brain cancer. So in this case, the use of pesticides or exposure to pesticides is what has likely caused the brain cancer. So the treatments are the level of exposure to pesticides. And lastly, what type of study was conducted? In order to determine whether this is an observational study or a randomized experiment, remember we need to look and see who assigned the treatments. Because the treatments were exposure to pesticides, this was not administered by the research group. Instead, the research group observed which adults had been exposed to a lot of pesticides and which adults had not been. So in this case, the treatments have already been administered and they were not administered by the researcher assigning random groups. So this is not a randomized experiment. It is indeed an observational study. Okay, now I have 3 comments to make about randomized experiments and observational studies, just kind of generally. First, randomized experiments try to eliminate as many differences between the treatment group and the control group as possible. So they try to eliminate any variables that might have an impact on the outcome other than the treatment. So because of this, if there's a big difference between the 2 groups, the treatment group and the control group, after the experiment, those differences are most likely due to the treatments. Nothing else, or as little as possible, was different between these 2 groups, so the treatments are most likely the cause of the differences. Because the researcher has less control over which groups get which treatments, observational studies tend to be prone to what are called confounding or lurking variables. These are things that are related to both the outcome and the treatment that can cause groups to have different results. So here's kind of a silly example. A study of 5 to 9-year-olds finds that those with a larger shoe size are better at spelling. Is the larger shoe size likely the cause of the better spelling ability? No, that's silly, right? If I have bigger feet, that doesn't mean I'm going to be a better speller. In this case, age is a confounding variable. That's because older kids are both going to have bigger feet, and they're also going to have had more education, and so they're going to be better at spelling than the 5-year-old kids. So age would be a confounding variable in this example. So because of this, because in a randomized experiment you can isolate as many variables as possible so that only the treatment is the difference between the 2 groups, and in observational studies you can't really do that so much because you have less control over where the treatments are assigned, randomized experiments are generally more reliable than observational studies. So if you have a choice to do a randomized experiment or an observational study, you should do the randomized experiment. As we've already seen, there may be some instances, however, where you can't do a randomized experiment. For example, in the Bordeaux region of France, it would not be ethical for me to expose people to pesticides that I think is going to give them cancer. We look at things that have already happened or at choices that people have already made that would not be ethical for us to administer. Alright, and before we end this video, we're going to look at 2 variations that you can have on a randomized experiment to help improve them just a little bit. The first way that you can alter a randomized experiment is to conduct a double-blind experiment. This happens when neither the subject nor the person delivering the treatment knows who is in each treatment group. Now, the reason a double-blind study might be conducted is because the researcher may subconsciously give away clues as to which treatment they're giving. For example, when administering the treatment to the group I know is getting medication, I might say, "Here you go, you're going to feel better." And when administering the treatment to the group I know is getting the placebo, I might say, "Here you go." And I might not do this consciously. This might just be a subconscious reaction, and it could be something as small as smiling or not smiling to the group. So because these little things might have an impact on the response, and we try to eliminate all of those little things as possible, we would conduct a double-blind experiment. So here's an example of that. The headache example from before is altered so that a lab technician numbers the bottles that the treatments are distributed in, writing down which bottles contain the drug and which contain the placebo. We do this so that we can track, right, which subject is receiving which bottle. However, it's not the technician that administers the treatment. In this case, a nurse, who doesn't know which bottle contains which treatment, is the one who distributes the bottles to the subjects. So because the person administering the treatment doesn't know which treatment she's giving, she can't give away any of the secrets or any clues as to whether it's the placebo or the medication. And by numbering the bottles, we can track which treatment each subject received so that we can see the outcomes appropriately. A second way we might alter a randomized experiment is to conduct a randomized block experiment. This is when you first group the subjects by similar qualities and then assign the treatments randomly within those groups. And you would do this if you think there's a variable that will influence the response that's different from the treatment, or you think the treatment might affect groups differently and you want to account for that. So for example, suppose the company thinks that the headache medication will help younger patients more than older patients. So they alter the experiment so that subjects younger than 40 years old are placed in Ward 1, and those 40 years of age or older are placed in Ward 2. Then, half the patients in each ward are randomly assigned the drug, while the other half in each ward is given the placebo. So in this case, we're grouping the patients by age. We put the younger patients in Ward 1 and the older patients in Ward 2. So those are the blocks that we're using, and then we randomly assign within each of those blocks. Alright, so that's it on our video on types of studies. If you want to review random sampling techniques, you can watch the previous video. In the next video, we will discuss some of the ways that a study might be biased, so you might be getting information that isn't quite correct. Thanks for watching, and have a great day!